move the orange dot to negative 2 plus 2i. So we have a complex number here. It has a real part, negative 2, has an imaginary part. You have 2 times I. And what you see here is we're going to plot it on this kind of two-dimensional grid, but it's not our traditional coordinate axes. In our traditional coordinate axis, you're plotting a real x value versus a real y coordinate. Here, on the horizontal axis, is going to be the imaginary part. So in this example, this complex number, our real part, is the negative 2.
There we go. All right.
And then our imaginary part
That's
is
better.
a positive 2. And so that right over there in the complex plane is the point negative 2 plus 2i. Let's do a few more of these. So 5 plus 2i, once again, real part is 5, imaginary part is 2, and we're done. Let's do 2 more of these. 1 plus 5i. 1, that's the real part, plus 5i, right over that im. All right, let's do 1 more of these. 4 minus 4i. Real part is 4. Imaginary part is negative 4. And we're done.
Alright, so now we just have the article. That was a quick video. The imaginary unit, or I, is the number with the following equivalent properties. I squared equals negative 1, and the square root of 1 equals I. Pure imaginary number is any real number multiple of I, like 3i or I square root of 5. Complex number is any number that can be written as a plus bi, where I is the imaginary unit and a and b are real numbers. The real part of the number, or a, is always a real number that is being added with the pure imaginary number. The imaginary part of the number, or b, is always a real coefficient of a pure imaginary number. And a real number. Yep. Just like we can use the numbered line to visualize a set of real numbers, we can use the complex plane to visualize a set of complex numbers. Complex plane consists of 2 number lines that intersect in a right angle at point 0, 0. The vertical number line, the y-axis, this one would be this one right here, is the imaginary axis, and the horizontal right here is the real axis. Every complex number can be represented by a point in the complex plane. For example, 3 minus 5i also is expressed 3 plus negative 5i. Having the real part of 3 and the imaginary part of negative 5, we go over to 3 on the real axis and down to negative 5 on the imaginary axis. So the complex number 3 plus negative 5 is associated with the point 3, comma, negative 5 in general. The complex number a plus bi corresponds with the point AB in the complex plane. So now we got to plot the point negative 4 plus 7i. Well, on the real axis, that's negative 4 plus 7i. So we just go up to 7, and there we go. Got it. And now plot the complex number of 6i plus 1. 6i, well, 6i plus 1. If we wrote that in standard form, it'd be 1 plus 6i. 1 being our real number, and 6 being our imaginary number. Plot the complex number negative I equals 3. So the real part is negative 3, so that'd be over here. And then the imaginary part would be this negative 1 that you're multiplying I by. Negative 1. There we go. Plot the complex number 4i. Well, there's no real number, so it stays along this imaginary axis. And it's just 4i. Plot the complex number negative 7. Well, negative 7 has no imaginary parts, so it's just along the real axis. And check. And there we go, that's it. And we're just going to do this quick practice. Alright, plot the point -3 minus 2i. Well, the real part is -3, and the imaginary part is 2i, so it's just 2. So we'll check. Minus 2i. So it's right there. Check. There we go. Point A, 8i, has no real part, so it's just along imaginary. 3 minus 7i would be, the real part would be 3, and the imaginary part would be minus 7. And -3i has no real part, so it's just -3. There we go. And that's going to be like the quickest stream I've ever done. About 6 minutes. Thank you guys all for watching, if you did watch. Bye.